about how to find if there is a cycle in an undirected graph in Python. So what I did first was created a node class. So if you see here's a node, you have a value and you have a parent and you have the rank. So as you see, I also use type annotation just to make everything more clear. So what I did was, this is the initial function, and let's look at the actual implementation of the code. So we have node, all the nodes. So this is all the vertices we have. So this is all the vertex we have, and I just created it. So for each node the value of the node is the index of the node, and the parent is none. So this is how you start. So we have nodes from 0 to 4, as you can see here. So we have from 0 to 4 all these nodes. And then this is the collection of the edges. So you have 0 to 1, 2 to 3, 1 to 2, 0 to 4, and 4 to 3. So all of them, they are undirected, so meaning you can go from 0 to 1, from 1 to 0. And now I'm looping over the edges, and I want to find if there is a cycle in the graph. So if there is a cycle, I will just print cycle and break the loop. So how we are doing this is as follows. We will first loop over the edges. For each edge, we will take the start and the end. We're gonna take the first node and the last node. We will check if the first node parent is none, meaning there is no parent. If there is no parent, so we will set that the parent node is the end node. And the end node, we will increment the rank. And then we will do the following things. We will check if the start node dot find set iter and end node dot find set iter is the same, meaning they are both pointing into the same parent. Then there is a cycle, and we will link both of the nodes, and we will print cycle and break the loop. Else, in the other case, if the end node dot parent is none, then the end node dot parent equal the start node dot parent, because there is already a start node parent, and we will increment the rank by 1. And eventually we can delete this line because we have already the loop. We can actually modify the code a little bit just to make it 100% proof case, like this. Okay, it can be else if it doesn't matter because we have the break here. So this is the code. We will run through it and see how it's actually changing. So we are collecting, you can see here the actual value. So the edge is 0 to 1, and we can see that we're taking 0 and 1. So we are selecting the first and the end node here. You can see that the end node parent is none, and the start node parent is also none. And now we will check if their parents are the same. Okay, because the parents are not the same. Okay, because both parents are none. So, meaning they are the roots. So now we will check this condition. So if start node of parent is none. So now we will point the start node into the end node. And we point into start node, meaning if we look at the start node, the parent is pointing at the actual node, at the end node. And then we increment the rank at the end node by 1. Now we continue. And now we're keeping this loop. So what we just did is take a line from 0 to 1. So this is the first line we have. And now we are going on. We have node 2 and node 3. So we will need to build a line from node 2 to node 3. I forgot to draw node 3. So we'll build the line here. The parents are not the same. They are. And then the start node of parent is none. Then we'll create a link and we increment the rank. So the start node is 2 and the end node is 3. And so I will also write the rank here. So the rank of here is 1, and the rank here is also 1. We can actually look at the ranks here. If we look at the edges here, you can see that the 0 rank is 0, the first rank is 1, and the 3 has also rank of 1. So let's keep going, continue. Now we are 1 and 2. So 1 and 2, the same. We are checking if they are the same. Because they are not the same, we are having that the start node is equal to the end. So the start node is 1 and the end node is 2. So 1 will point in 2 and we will increment the rank. So a slight modification is needed here. I'm just seeing it now. And now we're at the end of the loop. So 0 to 4. So there's one more loop after that. So start node, end node. We're checking if the parents are the same. They are not the same. And now this is the third case. So the start node of parent is not none because 0 has a parent. And the parent of 0 is actually 3. And if you are wondering why 3 and not 1, because when we look at this function, find set iter, so what it will do, it will also find the set and will fix that node to already point at the root. So it will check if there is no parent. So if there is no parent, then it will turn itself because this is already the parent. Else it will take the current element and will try to find the maximum parent. And when it finds the maximum parent, it will set the actual value of the parent to be the end root, and then it will return it. So it will make everything a little bit faster. So the end node dot parent equal the start node dot parent, and then we increment the end node rank. We should increment actually the start node, but I cannot change it now. So continue, and now we're at the end of the cycle. So we will look at the end node and the start node. So the start node is 4 and the end node is 3. So if you look at the start node, which is 4, and you look at its parent, it's 3. So now when we run this line, it will equal true because they have the same parent. And then we will link them together, which linking mean we will check which one of the rank is greater, and which one is greater we will set as the parent. So if the rank of the first element is greater, we set n2 to the parent equal to the first element. But because the first element rank is 1 and this element rank is also 1, we'll set the n1 dot parent equal n2, and then we will increment the rank. Just to follow up, so what we did was line by line going on each element and drawing the edges. So if you would look, we'll just do it one more time. From 0 to 1, from 2 to 3, we have these lines, and then we have from 1 to 2. So from 1 to 2, we already have it, and then from 0 to 4, so we have from 0 to 4, and then we have from 4 to 3, and now we have a cycle. And then it's print that we have a cycle, we're linking them together, and then print cycle and break the loop. So that's it. Hope you have fun, and until next time.